In our previous tutorial, we encountered this audio metadata, which is a Python class. So we were running these lines of code here when we had the TorchAudio.info that returns this metadata, and this metadata has this sample rate, number of frames. We talked about this before, but let's take a look inside this metadata. So we see here this metadata, the source code. We have a class keyword, and we use this class keyword to define classes in Python. Classes, they provide a means of bundling data and functionality together. So creating a new class creates a new type of object, allowing new instance of that type to be made. Each class instance can have attributes attached to it for maintaining its state, and classes instances can also have methods that are defined by its class for modifying its state. When we investigate this source code for this audio metadata, we see that it's a class, so we are using this class keyword to define a class. Here we can put the name of our class followed by 2 dots. Then there are some doc strings to tell what this class is doing. Then we will have here some functions inside these classes, which are also called methods, and there are some special methods, for example this init. So this init can be seen as a constructor in C++, for example. So it would be the equivalent of a constructor in Python. We also have this special string method here, and we see that these special methods, they have 2 underscores before and 2 underscores after. We see that there is this special word also called self. So we will talk about this self a bit later on. I think the best way how we can understand classes is to have an example. So here we will define our class, and it will be a guitar class. The name of this guitar class will be my guitar class, and this is a class to have information about guitars. So the guitars class have the following properties. So we have some attributes. There will be the attribute called name. It's a string representing the guitar's name. Price, which will be a float representing the guitar's price. And the number of strings, which will be an integer representing the guitar's number of strings. In this class, we'll have some methods. So there will be a method called getName, and it will be a function that returns the name of a guitar. That will be a method called getPrice, and it's a function that returns the price of a guitar. There will be a method called setPrice, and it's a function that sets the price of a guitar. And there will be a method getNumberOfStrings, which is a function that returns the number of strings of a guitar. So this is the documentation for our class, my guitar class. After this documentation, we have here a variable called number of strings, and it's defined as 6. This is the standard number of strings of a guitar. So I'm putting this number of strings here just to show the difference, that here we have some variables inside this init, inside this constructor, and here there is this variable outside of this constructor. So in theory, it's not mandatory to use init. You can simply define classes with some statements. So in practice, the statements inside the class definition will usually be function definitions, but other statements are also allowed, and sometimes they are useful. So here, for example, it's an example where they're having this my class. They have some simple doc string here. So they are defining this I equals to 1, 2, 3, 4, 5. Then they are defining this function f with this keyword self, and this f will return hello world. And if you have this myClass.I and myClass.f, they are valid attribute reference, returning an integer and a function object respectively. So this is a very simple class. There is no init method, there is no str method, there is just one variable here and one method here defined like this. In our case, we will have this init method, but we also have this variable here outside init. But this init we should consider it as a constructor, so we can pass these values when we instantiate a class. So this init will return a guitar object whose name is name and price is price. So we can also pass default value, so the price. If we don't pass when we create this object using this class and we don't give any price to it, it will be 0. Here we have this name, then here we have the self. So name and price are normal variables that we can use, but now we need to take a look at self. The self parameter is a reference to the current instance of the class and is used to access variables that belongs to the class. Have in mind that it does not have to be named self. You can name it whatever you like, but it has to be the first parameter of any function in the class. So here we are not using self. In this example, we're using mySillyObject, and then in this init, in this constructor, it needs to be the first parameter, and then you have this mySillyObject.name equals to name, mySillyObject.age equals to age. Here we are not using self, but it is a reference to the current instance of a class. We will understand these concepts better in an example. Before I continue talking about these other methods of this class, so we know that there is a class named myGuitarClass. There is a variable inside this class that's called number of strings, which is defined as 6. Here we have this init that we can be seen as a constructor of this class. And this, now we have a variable called name, a variable called price, and we have a reference to this class. So if we will tell that I want to create a guitar, and this guitar will be a Fender, so the name of this guitar is Fender and the price is 100. I am using this Fender equals to myGuitarClass Fender and 100. Now if I have here this Fender, it is myGuitarClass. When we take a look at it, is myGuitarClass. This Fender guitar costs 100 euros and it has 6 strings. So this is the string from this class, and this init docstring returns a guitar object whose name is name and price is price. So this, we have this from this init here. This is the init docstring, so returns a guitar object, the same as here. And here this string form is defined by this method here, but we will get there. If we try to create this Fender guitar without passing any parameters, we have an error because the init is missing one required position called name. So we see here that in this init we need a name that is not given any default value, and there is the price. So if we omit the price but we give it a name, so it will be just Fender. Now we have that the Fender, let's get it, name is Fender and price is 0 because the default value that we set here is price. If we would now have here like before, so this is 100, now the Fender price is 100. We also have the number of strings, which is 6, but we see that we don't define this. We cannot change it when we will create this object from this class. We are just passing name and this price. Of course we could remove this from here and include it here, so self dot number of strings, and it will be, so we comment this out here. After price we put number of strings, and let's say that it's 6, and here the number of strings is also the number of strings. So if we pass the number of strings, now we have, let's put here, now it's 4 strings, so now Fender dot number of strings is 4. So far we understood how to create the class using this class. We can put some documentation here, we could have many statements here, but we are using this init, and we can see that it's similar to a constructor. So when we will instantiate this class, and we will have this Fender now is the type of Fender now is a my guitar class, and you will have all these attributes and methods. So if you Fender, and you have the number of strings, you have this get name method, get number of strings method, get price, the name, the price, and a method to set the price. So let's continue here. We already understood this init, what it is doing. Now we are defining a function called get name, and this function will return the name of a guitar. Similar to it, we have this get price, and we are using the self. That means that it's a reference to this current object, and we then have this self.name, because name is part here of the constructor. And we will also have this get number of strings that returns the number of strings of a guitar. So we're returning self number of strings. Then we are having set price. In this case, the set price takes another argument. So we have the self and the argument, and we are setting that the self.price is the new price that we are passing to it, and it will also print the price of this. This is a string. Self name will go here, was set to self price, goes here, and we already talked about this is an old way how to format strings. And we are defining this string that will return this name guitar costs, the price, and it has that number of strings. So when we try to print this Fender object, what it will do, it will execute this method here. So this Fender guitar costs 100 euros and it has 4 strings. So we're printing Fender. If we don't have this method here, so let's comment it out. So now it's not printing this what we wanted it to print. It's just displaying this my guitar class object at this address here. So when we define this str method, then we can print. So let's use some of these methods. So we have a Fender. Let's put, it's not a bass, that's a guitar. It's not so cheap, plus 1,000 euros. So we have get name, it's a Fender. We can get price, it costs 1,000 euros. If we get number of strings, and it has 6 strings. So we can also change the price. So if we will set the price, and the new price will be 2,000 euros. The price of this Fender was set to 2,000. So now if we will print Fender, this Fender guitar costs 2,000 and it has 6 strings. And if we check, we can also print the Fender price like this. So we are not using the get price, but we are directly trying to access this price, and it's 2,000. Let's imagine that we want to protect this variable price, that no one can change this price or access this price directly. So you can only change this price or access this price if you use one of these methods. So this is very useful to make your code robust, and if some other developers they try to change in a way that will disrupt the mechanism of your software and you don't want that this happen, you can use this convention that this will make an effect on this variable, that it will not be accessible from outside of this class. You can still use it inside of this class, but you cannot use it outside. So I've just replaced here this price with this double underscore, also in the get price and in the set price. So now when we create our Fender, if we print our Fender guitar, we have the price that the Fender guitar costs 1,000 euros and it has 6 strings. But if we try to access this price, it's saying that my guitar class object has no attribute price, even though it's inside here. If we try to do the same thing with name, we get the name directly, but we cannot do it with price. So now we need to use the get price, and we have this 1,000. For the same we can do for a method. So if we would define this as get name, now we could use this get name inside of this class. So we could define a new function here that would return. So for example, let's print, when we get price, let's print the get name. So inside this get price we are printing this get name, and then it returns the get price. So let's try it out. Now if we have this Fender dot get price, so it's printing the get name, and it's also returning us the price. But if we try now to access the get name from here, there is a problem because there is no attribute get name. So if we remove this, so we don't need this anymore, now we have our get name and we get Fender. So pay attention that now also when we check which attributes and methods are available, we just have the name here because the price is not being displayed.